Hello, welcome to my channel. I am Ameya and we are discussing about control systems, in which today we will talk about why do we use Laplace transform in control system. In previous video we talked about the mathematical modeling. Okay, so we have tried to model various functions of differentials, okay, in our system. Now we are about to discuss why do we need Laplace transform. Now in control system we all know we work in different domains. Okay, so right now what we were discussing about differential equation, that is the time domain. Then the second domain which we work in control system is the S domain, or many of them call it Laplace domain. And third domain which we deal in is frequency domain, that we will see later. Now let us understand why do we need this Laplace transform for a control system. So we will just talk about a basic reason. What is the Laplace transform? Laplace transform L of f of t is basically f of s, which is a function domain, integral 0 to infinity f of t e raised to minus st dt. So what basically Laplace transform does is, we need to understand some basic rules of Laplace transform. Laplace transform of 1 is 1 upon s. It's the simplest possible term for a single variable, and our derivatives will definitely give you. Let us try to understand what is the derivative of Laplace transform dx t by dt. By simple formula, you can easily check that Laplace transform of this derivative terms will be s into x of s. So if it's a double derivative, that will switch to s square x square into x of s. So this derivative is basically get converted, differential equations are basically getting converted into a multiplication of s, which is our variable in S domain. So what basically we do is, if we want to go from time domain to S domain, we take the Laplace transform, and from S domain to time domain we take inverse Laplace. Okay, what happens to the integral? The same thing will change to 1 upon s, or 1 upon s raised to n in terms of integral. For derivatives, it turns to 1 s raised to n into x of s. That is how the Laplace transform simplifies your problem. Now what happens in after conversion of Laplace transform? Let us understand this equation: m d2x by dt square plus d dx by dt plus kx equal to fn. The same equation I can directly convert into m s square x of s plus ds into x of s plus k x of s is equal to f in, that is f in of s, and I can easily manipulate this by f in x of s upon f in is equal to 1 upon ms square plus ds plus k. So what happened here is, my whole differential equation is getting converted into polynomial, which can be easily solved. Okay, so we can easily solve different degrees of polynomial mathematically. So mathematically it becomes very easy. If it's a complicated system, it is surely not going to be second order. It can be having multiple orders like 7, 8, 10 order system. So that effectively makes it easy to solve in Laplace transform. So that is the first reason why we get into the Laplace transform. And then these polynomial equations are easy to plot, easy to find the roots, easy to control. Okay, so that's why we basically convert everything into a Laplace transform, that is S domain. We solve it there, we try to define a control system for that, and then get back to the time domain for different uh, outputs. Okay, so that is the reason, the basic reason for where we convert everything into a Laplace transform for a control system is converting into a simpler form, that is polynomial equations, and you can easily solve the polynomial equations for different values to understand behavior of a system, understand stability of a system. Polynomial equations are very easy to solve. Okay, so that is the reason, the basic reason for which we convert everything into a Laplace transform. And there is a third domain called frequency domain. We will talk that in detail when we go to the Bode plots for the control systems. Okay, so this is what I want to discuss in this video, why the Laplace transform is important for a control system. And one need to understand the basic rules of Laplace transform. Those are enough to understand the basics of control system. Then you can start performing various operations on mathematical modeling and convert into a Laplace transform to understand the basics of control system. So this is what I want to discuss. If you like this content, do share my channel with your friends, subscribe my channel, and do check the playlists which are available on my channel for control systems and mechanical measurements. Thank you for joining.